Hi, everyone. Welcome to another episode of the Humans and Wildlife Show. My name is Georgia Terry, and with me, as usual, is my co-host, Dr. Christian Sase. Christian, what are we going to talk about today?
Yes, hi everybody, and sorry we had some technical problems which we're trying to solve. I first of all wanted to say I hope you can hear us well. Just let us know if there are any technical problems which we have resolved. Anyway, very nice to be back with Georgia. It's number 17 now, is it? I have lost the
I think
count.
so, yeah. And Christian is being very nice. What he means is hopefully you can hear me now, because my sound was being a bit strange earlier. So, yeah,
Well,
do let us know if we're coming through clearly.
okay, very good. And thank you for all being here. Well, this is a great topic, really. It's a topic that came virtually out of the green, I should say, not blue. It came out of the green, really. That
Or did
one
it come out of
evening,
the
yeah,
black night sky?
it certainly did. And that's what we're going to talk about. It's going to be the Aurora. We're going to talk about, yeah, I'm going to give you a bit of the background of the Aurora. And then, Georgia, what are you going to talk about?
Yeah, so Christian's going to talk about like the aurora as a phenomenon, like what causes it, and I'm going to talk about how it relates to animals and wildlife. So can they see it? Can they sense it? They're probably not gaping in awe at it like a lot of us humans are, but how does it affect them?
Yes, and James has just put his put the nail hit the nail on the head. He says any technical problems should be blamed on solar interference. So there you are, Georgia, perfect. So we have no problems whatsoever. That's great. We're going to talk about that too.
Yeah, it does sound like David Howden says that my audio is a bit crackly, which is the problem we were having before. So I'll try to be more concise than normal, I guess. I feel like normally I talk a lot, but
Yeah, we're sorry. We know how important audio is, but really sometimes these things just happen. So just please be patient with us, and we'll sort it out. We will. Okay. So I'll get going. I'll start. Let me start giving some of the background. So I'll just go on full screen 1 second and give you some of the background. Why this topic? Well, this is really exciting. Let me go back one stage and show you really why the why the aurora in the first place, why it was taken. I just shrunk myself, shrinked or shrunk, whatever you want to call it, made myself small, and behind you can see one of the first shows I ever did on HAPS, and that was in May this year, just when HAPS was just starting and so on. And I was so excited. I was out there in the Okanagan with my camera, trying to show you live what wildlife is. And that's what I really love doing. And the picture that you see there in the background, if you look right in the middle, you'll see there's a nest, right? You see the nest, and it overlooks this beautiful Okanagan lake. And I had it in my head, I want to show, people on HAPS and just what wonderful wildlife it is. But it was a killer, and I even mentioned that word in my broadcast to get up. I'm sort of fit. I try and keep fit, but my goodness, when you have so much heavy equipment, you're trying to show something live. It's very difficult, really. Plus the technical issues, right? That I had to give you good quality. So then I started thinking, and here's the lucky part. We have a small summer house nearby. And if you would get on the roof or on the height of the roof, you could just see that beautiful osprey nest that you're seeing there. And that made me so excited. I thought, wow, that's fantastic. That's an osprey nest. Maybe if we got a camera, it would be possible to actually see it. So the next months I spent on the design. Yeah, you see it. That's great. That's great. So you see it. So the next month I spent on researching security cameras and everything, and going to a lot of detail to try and see how could we actually. And in the meantime, I knew the distance to the nest was about half a kilometer. What's that? Well, maybe a third to half a mile away, right? Still quite a distance away, right? So you needed a very powerful camera. So I started, and it had to be weatherproof, and my goodness, so I spent weeks and weeks and weeks looking into this. And finally, of long story short, I got this installed this camera with help of a company on the top of the roof, and it could rotate and be then red, and it could zoom in on the nest, which was exciting. And I'm just going to demonstrate that to you very quickly. Just give me a second. Let me see if I can do this. So how does this work? So how does this work? Behind me, you see that's a live view of the camera pointing to the nest, which is super exciting, right? So I've got, you can see controls here on the side, which I'm going to, um, uh, um, so I'm pressing these controls, and you can see the camera's rotating, right? So it rotates to the right. Today it's a very foggy day, right? So I won't show you, but I can rotate, and you can see here I can zoom out. Very nice. You can see how far this goes, right? So this goes incredibly far, and we can zoom right into the nest, which is incredible. All the way, like I can even get closer than that. And so that's not bad. That's not bad. So that was possible with this camera. Of course, that made me super excited that I was able to suddenly do this jump and for the first time be able to watch raptors live. And now something amazing happened in the last days with help of my friend Mark Horner, who is on the camera when I don't have time. He actually saw that bald eagles landed in the nest a few days ago, and we don't know whether they're going to stay or not. But it's just beautiful footage here, as you can see, and that was against the sun. The sun was coming, sorry, sun was coming from the back, but you see they seem very happy. We never know with the eagles whether they're going to stay or not. In the meantime, they come and go, and they're getting ready to find themselves a new home, right? So of course I'm super excited, because there would be nothing more that I would love to show you, is just another nest, right? Another nest like this. And to be able to show you that in high quality. And we don't even know what's going to happen when the ospreys come back and all that. We're going to find out anyway. So I just thought you would, thanks for this wonderful clip, Mark. It was really wonderful. So that's Beyond 90 Seconds. Mark Horner's YouTube channel is very nice. So that's the nest at the moment. It's empty, but when the sun comes back, then there's more action and so on. So who knows what happens? But anyway, we'll be able to we'll be able to watch that. So it turns out to be. Let me just jump back and make sure I see your comments now. Amazing, isn't it? Awesome. Yes, yes. So it is. Shout out the camera make model. Yes, I will, Craig. That's a great zoom. Yes, it's crazy. I will do that. When Georgia is going to talk later, I promise I will put the link in. Hi, Pablo, too. Hi, everyone. I will put the link in for the camera. Now comes the other thing. So I thought the main objective of the camera is to show wildlife, because that's my passion. I have another passion. I love astronomy, and I love the night sky. So obviously I started watching the moon and all kinds of stuff. And that's a picture of the sun on the 11th of February when I was on holiday with my wife in Banff, Alberta. And I couldn't help always looking at the camera. I know one shouldn't do these things, but I couldn't. When I came home, I would always see, well, what's the camera doing and so on, what's going on. So yeah, I was looking, and it was cloudy, and you can see that's a picture of the sun actually, right? And if you look carefully in the center, you can see there's a spot there. Do you see that spot? Well, that spot you usually cannot see because the sun glares too much. It's far too bright. But with a cloud cover, it acts like a filter. And was actually to see, I say, wow, that's a big sunspot. This next solar cycle seems to have really started. This is great. So I went on the solar activity website, and I saw, hey, there's that is true. There's one big sunspot, but there's another one on the side that you can't see at the moment that seems to be causing a solar flare. So that's a big outburst. We're going to talk about that in a moment. Directly going towards Earth. And I thought, that's amazing. I must keep my eyes open. Although I thought, I've lived in Sweden, and that's 60 degrees north, and I've seen so many auroras, and we'll get to that in a moment. Hi, Ari. Nice to see you here too. Yeah, I've lived in Sweden, and if you've lived in the northern countries, you will have seen so many auroras. So will you have, of course, if you're in Edmonton, in Canada, in Alberta, or you go further north to what is that called? Yellow. I've forgotten the name. Well, gosh, Yellowknife. Yeah, Yellowknife is the name, right? I haven't been there yet, but the more north you go, the more activity you see. So I've seen plenty, so much that sometimes I got irritated because we saw it every single night. But well, now comes the amazing thing. Is it possible for ruining lens with the sun? Yes, Kit. You've got to be careful with this with the sun. So the security cameras are built for that you can look directly into the sun. They will. It's quite amazing. They're so robust. They're so weatherproof that you don't that you don't actually ruin it. I usually put the aperture very small. Okay, so I do manual control when I look directly into the sun. Put the aperture very small, limit the amount. However, you're absolutely right. There's still a lot of light coming in, so you've got to be careful. I wouldn't do that with my normal cameras. I can tell with my beautiful lenses, I would always put a big solar filter in front. Hi, Derek. Nice to see you all. Okay, so that's the story. So that was on the 11th of October. So I thought, well, good to keep up. And now comes the amazing thing. I turned at that on the evening. We're just back in the hotel, and I was playing around with the camera, and then I turned the camera, and this is unbelievable. I turned it northwards, and this is what I saw. I actually gave a live stream of this. It was unbelievable. It was really beyond belief, because this is Kelowna, right? This is 50 degrees north, right? 50 degrees north, where the camera that I just showed you was positioned. And I was seeing these things, and this was like out of this world, right? And it was fabulous, wasn't it, Kit? It was fabulous. And it went on all night. It went down and up, and it got more and more intense. And these are just live videos, isn't it, Georgia? It is so beautiful. And this is so amazing. These were just these beautiful cosmic dances going on. I couldn't sleep all night. I was so excited, right? It was till morning. I was just there, and fortunately, I recorded the whole night. That's the nice thing, and I broadcast this. And thank you for the nice award, nice view award, and also thanks, by the way, to Peter for the high award, and also to David for the high award. Thank you so much, my friends, for doing that. So that's what was so amazing. So that's the history behind the behind this. I was going to show you also. Got a beautiful moonrise. Maybe I'll show it later. But I have a beautiful moonrise somewhere. Let me see if I can quickly bring it up. 1 second. Where is the beautiful moonrise? I was just going to show you that too. Yeah. What you can do with this camera, you're going to be thrilled when you see this. This was done 2 days ago. Let me share my screen again. This is what you can also do, right? This is about 8 minutes. Let me just put this in the beginning into a few seconds, and that's what you can. I should become a retail seller for these cameras, but this is what I did. Just pointing the camera at the moon, and it's just marvelous, isn't it? That you can enjoy nature day and night, and just share it with the world, right? It's just incredible. So it's just this beautiful balance there, and the light, and it's just really magnificent. Okay, so let's get back there again, and let's see. Yes, so anyway, let's get back and let's talk a little bit now about auroras. Where do they come from, actually? So ever since human nature started, and that was many years ago, they probably saw much more intense auroras than we ever did. They must have been mind-boggling beautiful, right? I mean, these, of course, exaggerated animations, but I can imagine that under really extreme situations, you would be able to see. Well, auroras really start right at the sun. Everything starts at the sun. The sun is, I mean, looks like such a beautiful giant that gives us so much light. But inside, it all starts in the sun's core, which is very hot. There's a nuclear reaction going on there at millions of degrees. It took scientists quite a long time to really understand the science of the physics of the sun, and we're still learning so much. So inside, hydrogen, which is in abundance at very high pressure, is transformed to helium, and that releases energy. This is what we call a fusion process. And during that fusion process, light is emitted. But not only light, it's so hot, it's huge plasmas, it's electrons, protons, it's all kinds of heavy elements. They are all floating towards the surface with strong convective currents. And then on the surface, you can see in this animation, well, it's not really an animation, but this is a time lapse showing you how incredible it is. And our Earth, you have to imagine, is just a single small point in that. So usually everything is fine. The sun, however, goes through what we call solar cycles. And we're now starting a new solar cycle. And that happens about approximately every 11 years. It's not exact, right? It's not exact. It shifts a little bit. And sometimes these solar cycles are extremely heavy. They can be very heavy. You have a lot of sunspots there. And that means the sun isn't just is neither a liquid, a solid, or a gas. It's really a plasma. It's a hot plasma. And these protons and electrons come from the inner the interior from the sun and get catapulted out, just like you see there. And they're huge magnetic fields on the surface of the sun. And they're usually, these sunspots are colder areas, right? And now and then you get a real mass ejection of the sun's surface, which we call then a solar mass ejection or a flare. And that happens. And sometimes when the sun is directed, the solar flare is directed directly towards Earth, we get the full bombardment. So first it comes past Mercury after a few hours.
Christian, of course that's okay. And I'm sorry.
Oh, sorry. Switching off my phone. Sorry. 1 second. Let me just switch off my phone. Let me switch off my phone. Sorry about that. That's what happens in a live show. That's okay. That was just my friend Mark talking. It's fine. So anyway, so they go past Mercury, then Venus, and then they come to Earth in about 16, 24 hours. Sometimes it takes a bit longer. Yes, they're called solar winds. That's exactly right. These are called solar winds. It's like a real hot wind with particles. And now comes the thing, the Earth's surface, actually, we are very well protected. So as the solar wind, thanks for the prompter here, for the word, hits the Earth's surface, we are protected by our own magnetic field, which is generated from the inside of the mantle from some rotation. And also that is highly complex, by the way. But we have a magnetic field, and that shields us. But this solar flare very often is so powerful that it does penetrate the magnetic field. And the magnetic field lines are not just a shield around the Earth. What they do is they concentrate on the North Pole and the South Pole, right? So there's a North and a South Pole, and that's also where the protection is weakest. And that's exactly why the further you go north or the further you go south, you actually see much more intense auroras. So now comes the question, so where do these colors then come from? Well, in the higher atmosphere, we're talking about 100 to 300 miles up in the atmosphere, the composition of the atmosphere is very different. There's a lot of oxygen actually very high up. And so what happens is these charged particles, could be protons or electrons, interact with oxygen, for example, or with nitrogen, and they cause these colors.
Sorry, yes. Christian, can you make the image a little bit bigger or zoom in on it some?
I can, absolutely. Yeah. I can. Thank you for telling me that. My pleasure. Let's do it. There you go. Yeah, that's better, right? Thank you, Georgia. Yeah, so that's just how these lines. So imagine the you may have seen these sodium lamps, these street lamps before. You know, these are these high pressure lamps. They emit certain lines. So imagine the Earth is just like a huge lamp. It's like a gigantic lamp out there in a magnetic field. That's really what it is. And then as soon as their energy comes in form of charged particles, these gases, and that's what it is. It's a gas up there, right? It's oxygen in there, and it's nitrogen. They get excited, and as they get excited, they emit light. So electrons get pushed to a higher orbit, as we say, and as it comes down, it emits light. That's what happens, right? Yes. So that's really how these beautiful lines are produced. So 200 kilometers and higher, as you can see the diagram, it's oxygen, then it's nitrogen, and so on. It's quite complex, but usually, I think the oxygen gives some of the green lines, the nitrogen some of the more blue lines, and so on. And then the red, I think, also comes in, I think, from the oxygen, as far as I know. So hi, Kat. Hi, everyone. Hi. Cindy says, with the shift in our north and south poles, our magnetic shield is weakened. Yeah, that's a great point. We'll talk about that. You know, Cindy, we'll talk about the shift of the magnetic field too. Yes, you're absolutely right. We are seeing shifts in the magnetic field, and actually, it is known. Let me just look when this event was. There was a major magnetic cataclysm 42,000 years ago that may have actually resulted in extinction. So here we have the connection to wildlife. So that is actually a well-documented line. So so this is just another view, by the way. Let me just also make this one bigger. 1 second. You see this properly? There we go. That's better. So you can see those are the different lines. So these are emission lines from all these atoms that are causing these beautiful colors, right? Absolutely amazing. So let's talk now about the human side. That's really what I was going to talk about. And also, 1 second, let me just get the screen back here. Oops. Where is my HAP screen? Wait a second. Here we go. Yes. Yes. I'm just going to quickly look at James's question. If you saw that aurora in Vancouver, does that mean they saw it in Yellowknife? Oh, yes, absolutely. How far a distance would a single aurora be visible? You know, it's interesting. I talked to David Dunn. He's an astronomer in San Diego. He told me that it could not be seen as low as San Diego. It really depends on the intensity. Auroras, by the way, also exist during the daytime, just that you can't see them because the sun completely, of course, outshines everything. But yes, Vancouver's 49 degrees. I would have thought, James or Gentleman Ghost, that we would have seen it probably just till about 40 degrees, maybe a little bit less. But there have been auroras that have been visible all the way down to San Diego, even also. So probably North Mexico or so. And conversely, the same happens, of course, in the South Pole. It's called the Aurora Australis, right? Australis. We have the Aurora Borealis, and they have the Aurora Australis on the South Pole. And often that's not talked about, but you know, countries like Chile, of course, will have incredibly intense, and New Zealand will see a lot of intense auroras too. I hope that answers. So now we get to the very interesting topic, really. What happens when we have these major solar flares? So we are now in the 25th cycle. That's what I was just mentioning. Okay, so let's start with it talking about the 25th cycle. It's just started, and it takes about 11 years. And at the moment, the prediction is the most common prediction by solar scientists are saying that very likely this is going to be a more mild one. However, that's not the whole story. It's so complex, and we're learning so much about the sun that there are other scientific articles that have been published that are showing exactly the opposite. They are predicting for 2025, and remember 2025, that there are going to be so many sunspots that we're going to have major solar flares in 2025. That's how much the models are differing right? I don't have any opinion. I'm not an expert on this. This is just my understanding of the science that I have read, but it is quite astounding how different the models are. So the sun is not really that tame. So let's go right back into history. Well, there's been in the year of 776, so 776, they actually found that there was a major change in carbon-14. You probably know that carbon is used for dating, right? For going back and seeing how old things are. That's carbon-12, carbon-14. And carbon-14, why carbon-14? Because carbon-14 is changed and influenced by a lot of the solar particles and the interactions. That's right. So in the year 775, 776, they saw a major change, and never again has that been recorded. There are two other records in history that go back 5,000 and 7,000 years from now. And this one has been the most recent one. And that is now believed from recent scientific publications to have believed to be a major solar outburst, and something that we can't even imagine, 100 times stronger than a major outburst that we had in 1875. It was, I think, 1870. Let me just get the date correct. 1 second. Sorry, no, 1859. I'm sorry. It was 1859, so-called Carrington Effect, which was the first major outburst one saw, and it took down many telegraph systems and equipment at that time. So that was huge. We've never had a Carrington event since then. And the event in 775 or so that really changed the carbon data, which, by the way, the Carrington the Carrington event in 1859 did not do the same. In any case, so this must have been a huge event that happened there in history, right? So we don't quite know exactly where this came from, but there's a lot of indication that shows that this may have been a huge outburst from the sun, 100 times stronger than the event in 1859. And if this is so, if we ever get this, I can only tell you, run, but run where? Because that's huge, right? That's huge. Thanks, John, for the award, and thanks, Gentleman Goes too. Thank you very much. Okay, so that gives you a bit of an introduction. Now let's talk about the technology that we have nowadays. We are so technically bound in everything. And James says, I'm surprised an event didn't happen in 2020 year from now. You bring up a very good point. And that's COVID, right? If you look at COVID and how difficult COVID has been for humanity to deal with it, and how much arguments and how many delays there were in decisions and so on, how difficult this whole thing has been. And COVID has been nothing compared to such an event. Can you imagine how we would cope with something like a super solar flare? I couldn't even imagine. It would be such chaos. And that's the scary part. I'm not here to draw doomsday. I'm just telling you, this is reality. We see things the way they go with COVID. And yeah, I think humanity in general is not very good at reacting with these things. Okay, so let's get into this. So there have been, I'm an electrical engineer. I actually designed transformers many years ago. So I understand the electric grid, I would say, fairly well, because I helped design them. And why is the electric grid so incredibly sensitive to solar flares? Well, it all has to do with transformers. So the way electricity is generated, you have a power station. That's where you have a high concentration of power initially, and you have to somehow distribute that all over. And the way we do that is we put the voltage up. So because voltage times current is power, right? So you put the voltage up, and then gradually you bring the voltage down through so-called substations, which have transformers. And you see these small transformers, especially in North America, you see them everywhere, and they distribute them all over to your household. That's the basic principle of the power grid. So the problem now is with these transformers. Transformers rely on magnetism. You may know that. You may have done this as a child. You have a magnetic core and so on. So what happens now is if you get a strong particle wind coming on, it will cause disruptions in the Earth's magnetic field. And especially when you're more north or you're more south, the further you're away from the equator, the stronger the influence of that magnetic field is going to be. So much so that in general, a lot of the electric grid companies have studied, have done intense studies on where the magnetic field lines would go during such a solar storm. So what happens now is, because the changes, even though you see a lot of fluctuation, they actually go very slow, and that's like having direct current, right? So what happens? It starts magnetizing the transformer core, and by magnetizing it, it means it's offsetting its balance. It's offsetting its balance. It's like putting some energy into the core which shouldn't be there, putting an offset in the DC magnetism, actually, and that saturates the core. It means there's no more resistance. I hope I'm not getting too technical here, but there's no more resistance. It acts like a short circuit and burns out the transformer. So what happens when a transformer burns out? Well, it's really bad. Not only because you say, well, who cares? I'll just use another transformer. The whole grid is connected. It's not that simple. It's not that simple. The problem is electricity cannot be stored. Just remember that. Electricity cannot be stored up to nowadays. I know there are ways of thinking about this, but there is no general electricity storage for the whole grid. That's the problem. So everything has to be in a fine balance. If you lose the balance somewhere, the others pick up more current. If they pick up too much current, you lose them too. It can cascade to a complete blackout. And that's actually what happened in Quebec when was it? Let me just look up when the date was in Quebec. That was in 1989. It was in Quebec. That's exactly what happened. There was a complete power outage for 9 hours. It cost millions. And that shows what can happen if you lose the grid. And because our grid is so interconnected, if that happened in North America, the whole grid could collapse if you had a major scenario like that. Okay. And in general, humanity is not prepared for these things. So that's what can happen to the grid. So what about you can see something else. You have spacecraft electronics that can be damaged. You have the telecoms that can be damaged. You have these so-called repeaters. You've seen these repeaters for cell phones. Oh, no. That's my watch talking to me again. You have these repeaters, and they can also be influenced. So it could be that we have complete blackouts of the cell network in very many areas, wherever the magnetic field is strongest. So, and it goes on and on with aircrafts and so on. So I think I've mentioned enough now. So if we had even another Carrington effect, as we had in 1879, it would really be very difficult for us to deal with it. So that's the human life and the solar flares. As much as we enjoy the auroras, we don't want them to get too strong. Okay, now I'll see how far Georgia is. How far are you, Georgia? Are you ready to jump in?
Yeah, I'm ready, I think. And I think some of the questions I have you can maybe help us with, because in researching about like how wildlife are affected by the aurora, auroras are a rare phenomenon, and they're really just an extreme, or what you get under particular circumstances of like disruptions to Earth's electromagnetic field. So so it can be difficult to discern like exactly what the impacts are on wildlife. So, for example, sunspots are another linked source, I presume, of like disrupting the electromagnetic stuff. And there's a lot, on how animals are affected by that. But I guess we'll just back up for a minute and say, like, okay, aurora, it's this cool phenomenon. What do the animals make of it? I mean, so depending on their eyesight, they might be able to see it, right? If they have good eyesight, or light sensitive eyesight. But also a lot of animals can pick up on magnetic fields, on electromagnetic fields, and so that's called magnetoreception. And
Right.
yeah, and so they often use it to navigate, to help them kind of have a sense of where the magnetic north is. And some animals, like sea turtles, create,
Mhm.
even beyond having a sense of like north south, they develop what's known as like a magnetic map.
Mhm.
So there's variations based on, like Earth not being a perfect sphere, and the crust is a little bit thicker here and whatnot. there's variations in the magnetic field beyond just north-south. And so animals that are perceptive to like the direction and strength of magnetic fields can develop like this into a map, and they have like landmarks. So what does this mean for animals? Well, a lot of birds use electromagnetic like orientation when they're migrating, for example. And so there's evidence that during auroras or area times when the field is really disrupted, that the birds, at least the birds in the north, they veer left a little bit when they're migrating. Or they tend to veer to one direction. So they're no longer like oriented true on what their migratory path should be. Um, but one of the really interesting things that came up
Mhm.
is that whale beachings also increase during, they're associated with the aurora. So like they think they are. And again, it's like it's
Really?
hard to tell, right? Because there's other things it could be, and there's also evidence that they're sensitive to things like sonar disruptions to sonar in the water. So if there's like a lot of underwater noise, like people testing underwater torpedoes or whatever, this might also be associated with whale beachings, and it can be hard to tell. But basically, there's evidence that the whale beachings might increase when there's auroras, because the whale's navigation is getting messed up by this
Yes.
electromagnetic stuff getting disturbed. Yeah. Um, and also, the same is true for honeybees. So, when they also looked at sunspots, and Christian, maybe you can talk in a second about how related or how similar a sunspot might be to an aurora for an animal that's trying to like use these senses. But like for sunspots, honeybees, when there was a lot of sunspots, fewer honeybees were returned to the hive. So basically, more
Really?
of them, when they were out collecting pollen and stuff
Wow.
from flowers, more of them ended up getting lost and not making it back to the hive if there was a lot of sunspots. And then there's similarly research on sunspots and whale beachings, where gray whales are stranded more when there's more sunspots. And also, this is the title of an article from Current
Mhm.
Biology. Gray whales are stranded more often on days with increased levels of atmospheric radio frequency noise. And
Yes.
so, from what I understand, the aurora or these like disruptions are linked with this noise too, correct?
Yes, yes. I, I mean, I don't, I know too little about this, but my initial guess would be that that whales are much more affected by the incredible noise that we make in the ocean, right? Rather than, I'm quite sure this must cause complete confusion for them, rather than some magnetic disturbance that we may have. And I'm quite sure if they are so sensitive to the magnetic field and so on, and as you indicate, there seems to be some evidence pointing
Yeah.
to that. Then the question that arises immediately is, how much disturbance are we causing, right, for them with everything we have? It's crazy,
Yeah.
isn't it?
Well, and I think that's where it gets hard to tell, because there are these studies out there that claim that it's like, oh, the aurora or whatever. But the whales have evolved for a long time with the aurora. They haven't evolved with like the human disturbances. And especially for, the aurora, you talked in the beginning about sometimes you would get sick of the aurora from
Mhm.
seeing it too much. So
Yeah.
it seems that animals that have to deal with it so regularly should be used to it. I do think there's cases where like the aurora comes down farther towards the equator than it normally does, and then the animals are like, "Whoa!" Like I found an old account of a whole group of honeybees, like or I forget what kind of bees. I think some kind of honeybees. They came to a hive where they would normally, come to this hive, but like they collectively all got lost when there was like an aurora or something. Like they all ended up like in a giant swarm at the airport instead of at the hive with their owner.
Mhm.
And this was during either like intense like sunspot solar storm period or during an aurora, I forget. Um, but yeah, so apparently it can be pretty confusing for the bees. and the whales and the birds. That's what I learned.
Yeah, I think, I think there's still so much we have to learn. It's also interesting because, of course, the disturbance of you know um, of all our surrounding, whether it's technology or animals and so on, is not only by solar flares. It's also the I don't know who it was who pointed out right in the beginning to say if there are fluctuations in the magnetic field, and they're quite a lot actually.
Mm-hmm.
If we would ever have a change from north to south suddenly, I can't even imagine what that could cause for animals because
Right. Well, so there are some cases of, like for example, if birds use this navigation ability, like when they're migrating. There's a species of swallow that
yes,
flipped its migration, right? It was sort of overwintering near the equator and then spending its summers farther north. And then a small group of them suddenly flipped, where they were still spending their winter at the same spot near the equator, but instead of going north, they would go south. So like maybe something like that happens on a large scale when the poles switch. But like you said, it surely there's a there's a well documented mass extinction that is related to the poles switching because so many animals their senses are like they're tied in. This is an important way of just how they sense the world. And I do want to point out another thing that I found is that we talk about other animals being able to sense the magnetic field, but
mhm,
humans potentially can too. So, or at least I should say that when they exposed, oh, let me pull up this article so that um, I don't miss miss use any incorrect terms. So there's a study that shows that they detected like different neural activity
mhm,
um, based on exposing people to what is the term? Let me look here. Static components of the magnetic field. I don't
okay,
know. So basically there's like a neural response in people that's sensitive to polarity in magnetic fields. But then that begs the question, okay, just because we have a neural response, that doesn't necessarily mean that we're aware of it. Like I certainly consciously don't know, and I don't even think unconsciously know. There's no kind of sense of this. So I think the fact that we can sort of see similar responses in humans as we can with other animals sometimes, I wonder if the animals aren't necessarily using it as much as we think in some cases.
yeah.
There's certainly, yeah.
Kit was asking like bats, so she's wondering if bats have. Do you know anything in that sense? If bats are sensitive to magnetic fields?
Yeah, so bats supposedly are one of the animals that can use the magnetic fields to navigate.
Okay.
And it can get very tricky though to discern. So, birds, bats, bees, whales, sea turtles, these are all animals that can supposedly use the magnetic field to navigate, but it can get very tricky because most animals don't just have one primary way of navigating, right? Like they maybe are sensitive to the magnetic field and have a magnetic map built, but they also can navigate by stars. So
Yes.
they have
Incredible. Incredible.
yeah, they have multiple ways to kind of know to navigate, and it can be very tricky to know which navigation method they're relying on. There have been studies, for example, where they raised birds in a planetarium. So the birds were raised and learned like these stars, but they had the planetarium shifted. So the birds learned the stars in a different position than normal. And so but the magnetic field was the same as normal in the planetarium, right? So the birds can still sense, like, oh yeah, this is magnetic north, this is magnetic south, but they learned stars associated with like an offset version of that. And when they brought these birds into the wild or exposed them to the real night sky, I don't know what they did exactly, but the birds tried to migrate the wrong direction. Um, so I think what that shows is that wait, let me make sure I have this set in my head correctly. So like the birds were primarily relying on the stars, not their sense of the magnetic north and south
Yes,
for their navigation during migration.
that is
But
absolutely astounding. That's astounding.
yeah,
Yes.
yeah, but if there's like no stars, like if it's like a cloudy night, I think they will follow like the magnetic. I don't know if they looked at these birds specifically, but birds in general, I think, will like follow the magnetic
Mm.
direction, orientation if they can't see the stars very well or something. So they have like a preferred navigation method and then like backup navigation methods.
Yeah,
Yeah.
David Howden is asking very interesting here. Is the
Mhm.
light from Aurora bright enough to allow day hunting animals to hunt at night? I can answer that indirectly. An observation that we made was absolutely fascinating, David. Exactly talking about David Hancock here. Um, they have these huge gatherings of eagles in the Chehalis, which is not far from Vancouver, due to the salmon run every November, sort of around that time. They come there, and what was amazing is on one night it was full moon, and it was absolutely clear sky, which is not often there because it rains a lot, of course, due to the salmon and so on. That's the way things go, right? But it was absolutely clear, and the whole of the Chehalis, the flats were covered with eagles. They never ever sit there at night, so they were obviously feasting out there on salmon at night, making use of moonlight. So that probably gives you an answer to you know what brightness uh, can do. So I would definitely say yes. Do you have anything to say to that, Georgia? Is there any
Well, I mean, I would add it's not just allowing daytime animals to hunt at night, but also like nighttime animals that rely on the cover of darkness and are used to that, exposing them to additional risk, right? So, like bats are, there's mixed evidence, but it looks like they're more suspicious on full moon nights or when the moon is really bright. They don't go out as much necessarily, or they stick to more shadowy areas, like places that are in the shadow of the moonlight, because they're at greater risk of being eaten by owls potentially, or other animals that have a visual component to their hunting. And so I wouldn't be surprised if like bats that don't normally see the aurora when it's out, they're like, whoa, no way, no thank you.
Yeah, and Cindy's comment, I'm quite sure, maybe you know, she says, Schumann resonance level change and affect brain waves with all animals as well as humans. I'm sorry, I don't understand this. So
Yeah, Cindy, it sounds like you know more about that than we do. You should tell us more, please. I don't know what Schumann resonance levels are.
yes.
Um,
Yeah, you completely lost me. I'm sorry.
yeah, we should. It sounds like we should invite you here as like a guest today or
You're,
something.
you're, you're you're very happy to join us for a future show. If there's anything, you're making very good comments. You're very welcome to contact us. And, if you want to come on board, that's wonderful. Okay.
Yeah.
Yeah. James says, would an aurora be visible at direct poles, similar views? So the answer to that is the best view you have, of course, from the aurora is from outer space, right? So from outer space, it looks like a ring around the poles. So I don't think that it's most intense at the poles. It is, and I don't know the exact answer actually to this gentleman ghost, but I assume, just judging from the outer space, it's around the poles at some at some optimum latitude, quite high latitude, maybe 7 degrees or so. That's my guess. So that's a good point.
Yeah. Well, and veering quite far from, I guess, the aurora, but just in magnetism in general. They actually, there's some evidence that there's bacteria that are actually sensitive to magnetic orientation. And
Really?
yeah, and I found that like there's these bacteria that will like line up according to like the magnetic like lines or whatever. And like that actually can help these bacteria, which are normally, they live by themselves, they're very
Mhm.
tiny, but it can help them line up with each other. And so it kind of potentially they're like, oh, this facilitates maybe like um the bacteria like forming colonies and stuff like that when normally they'd be dispersed, or it could even like have helped be a link between like single-celled life and multicellular life, if like it's a way to help facilitate like multiple different cells aggregating together. um, well, and I should mention too, I forgot to mention this earlier, but like there's two proposed ways that animals could sense the electromagnetic field. One is basically these two general ways. One is basically that like there's some sort of protein or small molecule mineral in them that is sensitive to magnetic direction. So like those proteins or whatever would like physically like shift their position, and the animal would somehow be able to sense that. And then the second way that's proposed that animals could sense this is by having chemical reactions that are sensitive to electromagnetic fields and forces. And how how animals even would sense the field is still like being discovered. So like there's some, for certain animals they're like, oh yeah, this part of the beak seems to be important, but like it's one of those things that like scientists haven't really been able to figure out, and that's part of what makes the question so difficult. Kind of like we still don't know why cats purr. Like we don't know like how they're purring, how they're making that noise.
Yeah, right.
It's like very difficult. Yeah, it's very difficult. Cats only purr, they don't purr when they're like in a CT machine or whatever. You know what I mean? I don't know. It's like difficult. It's difficult to figure out what's going on because, the magnetic field is kind of going through us all the time and piercing everything, um, it's difficult to take measurements in situations where you're not going to have any contamination of magnetic field. It's
Mm.
I know a guy that studies this, and maybe we should get him on, but like,
Yeah.
he does a lot of his research in these. There's like a copper room, for example. I think it's a small room where like the walls and ceiling and everything are just like made of copper, and to help block out the magnetic field, I believe. Does that make sense, Christian?
It could, yeah, no, that certainly would, absolutely, of course. I mean, that's completely correct. Magnetic field is basically susceptible to conductors, so you can completely shield off magnetic fields that way. That does make sense. Yeah. Mhm.
Yeah. Yeah, but it's very difficult to do, to study. So there's still a lot to be learned when it comes to wildlife and auroras and magnetic fields in general.
Right. So anyway, that's all I had to say. Is there any other point you want to make, Georgia? Is there any other? I mean, this has been lots of interesting points and curiosities and questions.
Yeah, I would say my final just comment, and this is not a point that we've touched on, but something for people to take home and think about, is I saw something online that was like light pollution, the common enemy of aurora hunters um, and animals. And it got me thinking about how, like, yeah, if we're not so spoiled like Christian, maybe I haven't gotten to see the aurora ever.
Oh, I
If you
hope
want,
you do. I hope you do.
I
Yeah,
hope I do too. Yeah,
you
it's like,
should.
oh, if you want to be able to see it, and if you want your nighttime animals to be happy, then we could all think about cutting down our light pollution as one of the sources of pollution that we're putting out into the world. Especially now is a good time of year to think about that, as like a lot of animals, more animals than normal, are out at nighttime migrating as the seasons change. So, yep, turning off your lights at night.
Stanley just says, any new developments about workers in strong electric current environments? So strong electric current environments. So you're not talking really about high voltage. You're talking about high currents. Yeah. I don't know if specifically any new developments. I just know that, gosh, we've all been educated with the health and safety of strong currents, which are more associated with strong magnetic fields, right? So if you have cables that are not shielded from, with as Georgia was saying, with some external shield or so, then you can have quite some strong magnetic fields going out, and you have to watch out, of course. I mean, you're talking about incredible power there. I certainly would be very careful. If you're talking about high voltage lines, typically there's a lot of questions of should people live below high voltage lines. There are also strong magnetic fields underneath. I certainly would be very careful. I have, anything to do with high power where we don't understand the interaction very well, I would be extremely careful with Stanley. That's my view. Okay. Oh yes, and Cindy makes an interesting the Schumann resonance. I'm going to read up about this. I don't know this. Okay, are a set of spectrum peaks in the extremely low frequency. So okay, that's a low frequency. So near DC fields.
Mhm.
Portion of the Earth's magnetic spectrum. Let me just read on. What does it say? Wait a second. Comment goes on. Schumann resonances are global electromagnetic resonances generated and excited by lightning discharges in the cavity formed by the Earth's surface and ionosphere. Okay, I'm going to read up about this. Thank
Yeah,
you.
it sounds really interesting.
Thank you for that. Well, uh, I hope you enjoyed this rather spontaneous session. We decided this morning, by the way, so it's caused some major havoc here between Georgia and myself, preparing this like crazy.
Yeah, and Christian just got such beautiful footage of
Yeah,
the
that's
of
what
the
it was.
aurora,
Yeah.
and sometimes it's fun to just pick like an interesting topic and see where it goes. So
Yeah, I hope you all enjoyed it. Thanks for taking part. So next week we do know who's going to be there. It's going to be a very good wildlife photographer. His name is Harry Collins. I know him from Instagram. Has exquisite things from Africa and all over. He travels a lot, does incredible photography. So we're going to talk a lot about his experiences with wildlife there. So it's something to look forward to. Oops, Georgia disappeared. I don't know what happened. That was an early exit. Maybe a solar flare just happened. That must have been all of a sudden. I don't know what happened to her. But well, on behalf of both of us, on Georgia and myself, I wish you a wonderful day still, a wonderful week. And